If an equation of a curve which is ax square plus 2hxy plus by square plus 2gx plus 2fy plus equal to 0, if this equation represents a pair of parallel lines, then h square is equal to ab, af square is equal to bg square. Distance between parallel lines is 2 root g square minus ac by a into a plus b, that is 2 root f square minus bc by b into a plus b. These are these are the conditions if a given curve represents a pair of parallel lines. Now let us prove these conditions if a given curve represents a pair of parallel lines. So let us assume for this, if the given equation of the curve S represents a pair of parallel lines. Now let us assume the pair of parallel lines as Lx plus My plus N1 is equal to 0 and Lx plus My plus N2 is equal to 0, because because the lines are parallel, coefficient of x and coefficient of y remains same, that is L and M, and the only difference between them is the constant term, which is n1 in first line and n2 in second line. So these are the two lines which are represented by the given curve S. Let us assume this. So now from this we can tell that S is equal to some constant lambda into line L1 into line L2. So that is equal to lambda into Lx plus My plus N1 into Lx plus My plus N2, because uh, this the equation of the curve represents these two pair of parallel lines. So S is equal to lambda into line 1 into line 2. So next let us solve this equation. Here lambda should be here lambda is not equal to 0, because if lambda equal to 0, then this whole equation will be 0. So S is the value of S is this, so which will be lambda into L square x square plus L m xy plus L x n2 plus m L xy plus m square y square plus my n2 plus n1 lx plus n1 my plus n1 n2. So let us multiply this with lambda. We will get lambda into L square x square plus lambda into m square y square plus 2 lambda lm xy plus lambda into m into n1 plus n2 into y plus lambda into L into n1 plus n2 into x plus lambda n1 n2 is equal to 0. So this is the equation after multiplying line L1 L2 with the lambda. Now this equation is also equal to S, which is ax square plus by square plus 2hxy plus 2gx plus 2fy equal to 0. So now let us compare S and the equation, that is S is equal to ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0, which is also equal to above equation. So now let us compare the coefficients. When we compare the coefficients of above equation and the given curve equation, what we will get? a is equal a is equal to lambda square L square, b is equal to lambda L square, b is equal to lambda m square, h is equal to lambda lm, then 2g is equal to lambda into L into n1 plus n2. 2 2f is equal to lambda into m into n1 plus n2. C is equal to lambda n1 n2. So if we compare the both equation, we can clearly say ax square, which is lambda l square, b, which is lambda m square, 2h will be 2l lambda m, 2 to cancel, 2g will be lambda l n1 plus n2, 2f will be lambda m n1 plus n2, c is lambda n1 n2. Now let us prove our first condition, h square is equal to ab. So here we can see h is equal to lambda lm. That implies h square is equal to lambda l square m square lambda square. Now a is equal to lambda l square, b is equal to lambda m square, and ab is equal to lambda square l square m square. That implies from these two equations, we can clearly tell that h square is equal to AB. So hence proved that if a given curve represents a pair of parallel lines, then h square should be equal to AB of the curve. Now let us prove our second condition, which is AF square is equal to BG square. So let us prove AF square is equal to BG square. So f square is equal to f square, we know 2f is lambda m n1 plus n2. So that implies squaring on both sides, 4f square is equal to lambda square m square n1 plus n2 whole square. Now 2g is equal to lambda l n1 plus n2, squaring on both sides, 4g square is equal to lambda square l square n1 plus n2 whole square. Now let us multiply the equation 4f square with a. So 4af square is equal to lambda square m square n1 plus n2 whole square into a. The value of a is lambda l square. So lambda l square, that will become lambda cube l square m square n1 plus n2 whole square. Now let us multiply 4g square with b. So 4bg square is equal to lambda square l square n1 plus n2 whole square into value of b is lambda m square. So what we get here, lambda cube l square m square n1 plus n2 whole square. So we can clearly see from these both equations that 4af square is equal to 4bg square. So let us substitute it here. What we get, 4af square is equal to 4gb square. That implies af square is equal to bg square. So our second condition is also proved here. So if a given curve S represents a pair of parallel lines, then h square is equal to ab, which is proved before, and af square is equal to bg square. Now let us go to our third condition. Our third condition is distance between parallel lines is 2 root g square minus ac by a into a plus b, that is 2 root f square minus bc by a into a plus b. Now our given two lines, which the two lines which I have assumed are lx plus my plus n1 is equal to 0, lx plus my plus n2 is equal to 0. So we know that a distance between pair of parallel lines is of these parallel lines is modulus of n1 minus n2 by under root of l square plus m square. So this is the distance of the distance between the parallel lines. So modulus of n1 minus n2 is difference between the constant terms of these lines, and by square root of l square plus m square, which is the coefficient of x and y in our lines. So the distance between parallel lines are modulus of n1 minus n2 by under root of l square plus m square. So this can be written as uh, square root of n1 plus n2 whole square minus 4 n1 n2 divided by L square plus m square, because n1 minus this is because n1 minus n2 whole square is equal to n1 plus n2 whole square minus 4 n1 n2. So we know that a minus b whole square is equal to a square plus b square minus 2ab, and that can be written as a plus b whole square minus 4ab. Similarly, n1 minus n2 in our given term n1 minus n2, this is written as n1 plus n2 whole square minus 4n1 n2. So that will be under root of n1 plus n2 whole square minus 4n1 n2 divided by L square plus m square. Now let us multiply both the numerator and denominator term with lambda square. So lambda square into n1 plus n2 whole square minus 4 lambda square into n1 into n2 divided by lambda square into L square plus m square after multiplying the both numerator and denominator term with lambda square. So next, what do we get? Which will be equal to, so here we can see lambda square by n1 plus n2 whole square. So here we got that 2f equal to lambda m n. So let us, previously we got 2f is equal to lambda m n1 plus n2, 2g equal to lambda l n1 plus n2, lambda m n1 plus n2, 2g is equal to lambda l n1 plus n2, and c is equal to, here we got c is equal to lambda n1 n2. So c is equal to lambda n1 n2. This is the these are the terms which you got. So also uh, so now what we will do is n1 plus n2, what is the value of n1 plus n2? So n1 plus n2 is 2f by lambda m. So n1 plus n2 whole square becomes 2f by lambda m whole square, that is 4f square by lambda square m square. So let us substitute it in the equation which is written here. Okay, so the value of n1 plus n2 is 4f square. So let us substitute it. What we'll get, under root of lambda square into n1 plus n2 whole square is 4f square by lambda square m square minus c is lambda n1 n2. So this term becomes 4 into lambda into c by lambda square L square plus lambda square m square. So we know a is equal to lambda L square, b is equal to lambda m square. So what we will do is, in the denominator we will take lambda common and we get lambda L square plus lambda m square, which is a plus b. So this is the term in denominator. So that will be equal to under root of lambda square cancel, 4f square by m square minus 4 lambda c divided by lambda into a plus b. So what will it become now? That will be is equal to uh, under root of 4f square, if you take m square LCM, 4 lambda c m square divided by lambda m square into a plus b. So we know lambda m square is equal to b. Let us substitute it in this equation. So what we'll get, under root of 4f square minus lambda m square is b, 4bc divided by b into a plus b. If we take 4 common from the numerator and bring it out of square root, we'll get 2 into under root of f square minus bc by b into a plus b. Now this is 1. Now here we can see that clearly, if we substitute n1 plus n2 as 4f square plus by lambda square m square, we get 2 root f square minus bc by b into a plus b. Similarly, if we substitute n1 plus n2 whole square as 2g by lambda L whole square, that is 4g square by lambda square L square. Then what we get here is, instead of f, we will get 2 into under root of g square minus ac divided by a into a plus b. If we substitute n1 plus n2 as this, so which is also equal to 2 under root of f square minus bc by b into a plus b. So from this we can say that if a given pair of if a given curve S, which represents a pair of parallel lines, if a given curve represents pair of parallel lines, then the conditions are then the curve satisfies these conditions. One is h square is equal to ab, second is af square is equal to bg square, and the third condition is distance between parallel lines is 2 root g square minus ac by a into a plus b, or this is also equal to 2 root f square minus bc by b into a plus b. So these are the conditions which we have discussed for a pair of a given curve for a representing a pair of parallel lines.